Bismillahirrahmanirrahim. I'll continue with my lectures in operation research, and my objective is to connect this operation research of management to civil engineering. Here is what we can do in terms of transshipment problem, and if I try to idealize a problem that is very much related to supply and chain management. I'm Adnan Kadir. So consider an example where contractor has been assigned to work in urban congested areas in three different localities. But these places are so congested that the contractor cannot store construction material on site. It was decided that those materials be purchased and stored in advance at two warehouses that the contractor owned in different parts of the city. These materials then be supplied to respective time and whenever and wherever needed. You are required to optimize supply of material using transshipment technique of operation research. Now, again, this is a given problem. There are three suppliers who have been assigned a task to first to supply from two warehouses, and from warehouses it should be supplies to the three site. So we have three supplier. It will be go to supply two warehouses, and from two warehouses it will supply to three site. These type of problem again required minimization. So what we have done, so what we'll try to do is to copy all of this here, and from all of this matrix to here, and we will add sum from of these three here, the sum of the rows, and we will have apply sum of the column to get this value. Similarly, on the bottom table, we'll have sum of the rows here and sum of the column here. We will use is equal to sign because the demand and supply are equal. So this is technically a LS problem. In defining of objective, now our objective, unlike in my previous lecture, my objective was only one, but here we have two matrices. So my first thing will be I will multiply this matrix with this matrix. So that's why some product from this cell to this cell, plus I will add the sum product of this matrix to this matrix, and that's it. And it's this is my objective function. Now my variables that I will change the values of these two matrix. I'm sorry about this two matrix, this one and this to get the optimized value. My constraint are this column and obviously this column, and similarly I have the demand constraint are this column and this column. So this is how we do this problem. And again, this is a very good example of how we are going to solve this problem. Let's go to this data. We use this solver function. Objective function is highlighted here. I'm interested in winning value, and I have to now change the value of this matrix. So that's why it's from H7 to H9, sorry, H7 to J9. And similarly, this will be an H of 14, H of 15 to J of 16. And again, then there are, these constraints. You all know that. So let's try to solve it. So I have got this value of these values. Let's say, okay. And these are the optimization values that I've obtained by solving this. So the cost will be 20,500. So that's how this problem, this logistic problem can be solved easily by using operation research technique. So thank you very much for your time, and I hope that I was able to I was able to convince you about the explanation of this problem. Thank you. Take care.